Hello, everybody. Good morning. Good morning. Today is a good day. So, the last time I started part one of this tic-tac-toe project in C, and today I think we're going to continue. But before we do that, it would be nice to quickly recap on the things we did previously. So I'll go to was it app? Yeah, it was app.c. Yeah, okay. So we have our tic-tac-toe project here. You can see everything is good. So we basically drew the board the last time. So we defined a board array here. It's a 2x2 array. I think there's something wrong here. Let me come down to this side. Yep. So it's a 2x2 array, and we define the data type as char because we want a single character in the cells. So this represents the cells of the board, the 3x3 board that we will be drawing. And the reason why we use char is because we'll be putting in a single character within each of these empty strings, and the empty strings basically is a single character. So hence the reason why we're using the char data type. So let's quickly run this. What I'll do is I'll just come here again, and I like the vertical terminal a lot. So vertical terminal. Okay. So here it is. We can clear this. I think we've compiled this already, but let me compile it again. A.app.c. So we put cc. It's just a shortcut for the compilation of the code. So we just put it there, cc app.c, and then we'll run our app. So automatically we'll have this a.out file that is created for us. I mean, if I remove this a.out file, you can see it's no longer there. So when we do cc app.c and do ls, you can see it's created again, right? So let's clear this and try to run the code. So after compilation, all we need to do is to do a.out, like /dot/ like this. You put a full stop or a dot and /a.out, and then you run. So you can see we basically created the board here, which is all we did the last time. So we need the board to be able to, display the steps each user has gotten to in the game. All right, so let's move on here. I'll close this window. This vertical tab, I don't know why it's not closing. This is how I quit it sometimes, which is not the ideal way. I need to find a solution for that. So the next thing we're going to do is to define the logic for the game. So tic-tac-toe is basically a 3x3 board game. And let me quickly open something here to display draw to display how the game works. So I'll bring this back here and open this whiteboard here. Okay, so we have something already here, but I'll just quickly clear this. So we will, first of all, we have our board drawn out already, so which is a 3x3. So we'll come here. We'll come here like this. I think this is fine. This is 1, 2, 3. Okay, we don't need the last column. It is an eraser, right? Oh, okay, erases everything. That's not what we want. Let me draw the board properly. I'll do it like this. 2, like this. 1, 2, 3. So this is the third column. 1, 2, 3. So this is a 3 by 3 column board. I think this is okay. 1, 2, 3. 1, 2, 3. 1, 2. This 9. Okay, cool. Even though this doesn't look good, I'll remove that. Remove this too. I think you can draw a line here. Oh, okay. This is better. So we'll draw it like this. Take another line from here. Perfect. All right. So we have our board drawn out. So the game is such that each player would take a turn. So let's say usually the representation of each player is X and O, right? So let's say player X plays. Player X will put his mark here in the first column, and in the first column, first row, and then the second player might put theirs here, right? The second play, the X again will take its turn. So it's like one person plays and then the other person will also play until the game gets to an end. And by the end of the game, it's either a player wins or they're both done and it's a draw. So we come here again, this player will put his X here, and then let's say this other player puts his O here, and then the X player will put his X here, right? Now this satisfies the condition for a win, right? You can see here we have the same value in the same column. So here this is a win, and for the second player, automatically they lose because this player has already won. There's no need for them to take a turn. But there are different ways to win in this game. So first of all, you can win from this column, or let me just put it, you can win column wise, right? Like this. You can win row wise. Sorry, you can win row wise like this from here to here. Okay, you can also, okay, this is another column for you to win through. I'll just put this here. You can also win going this row. This is the bottom row. This is another row again, right? Okay, there's a third column for you to win in. If you have your values throughout this column here, you can also win. But now there's another special case, which is diagonally. So you can win going across the board like this, right? Here to here, and then from here to this place. So these are the conditions for winning this game, right? So now, if you observe very well, for us to do this in code, we need to know the points that represent the winning cases, right? So for example, going this first column down, right? Remember we drew the board using indexes of from I all the way to 3, and then we also iterated a second loop. So when you look at our board here, we have a 2x2 board, a 3x3 board, sorry, and this board has items at various positions, right? So here, this will represent our first column, right? This will represent our first row, because the array within this bigger array, or the parent array, is the row. It represents the row. And here we have also another row, but going down the board, because we can't visualize this properly, it's like in a flat form, right? We can see here, this is column 1, This is also at column 1 but row 2. This is column 3. I mean, this is column 1 still at row 3. So again, we can represent this by indexes, right? So let's go back and clean all of this away. Let's remove all of this from here, and then we'll put in the positions for winning. So for the column case, right, winning column wise, you win from here. So this will be 0 at index 0. Again, this is the first row, right? So this will be 0 0, first column, first row. Again, first column, first row is at index. First column is this array here, right? And then the first row is still this place. So first column is the first element of this inner array or child array, and the first row is here. So we want 0 0. Again, let's open our board back. I just closed it now. Okay, that's not it. Yeah, this is it. So okay, so we are back. This is 0 0. So this is the first row. Again, first column, we are still in first column. So to access this first row here, we will do 0 0, and then here we'll have the second column. Again, this is still 0, but now this is the first array, right? This is the second array in the 3 by 3 array, and then this will still be 0 and then 2. Again, we'll move on to the next one. This will be 1, and then this is still the first array, so 1, and then this will be 0, right? Let's go back again and observe this. So we have here this second column will be 1, so 1 will be, okay, it's still 0 0, sorry. So this is still the first array, right? Hold on, I'm coming. So we have here first row, second row, third row, but we are first row, second column, first row, right? Second column, first row. So it's 1 0. Okay, 1 0. First column, second column, first row, 2, and then 0. So because we are representing the wins across the table, I'll use a different color here. I mean, it doesn't matter anymore. So let's just do 1 and then 0, 2, and then 0. Again, here we are now on the second column, 1. So we'll do 1 1, and then this will be 2 and then 1. This will now be 1 and then 2, and this will be 2 and 2. All right, so if we're able to locate this, so these are like the representation of each cell, and if we're able to locate all of this, we'll be able to point out the winning cases, right? So again, we'll still go back and write the actual. So these are like index representation counting from 0, because I'm not counting from 1. But if we're to count from 1 all the way, so here you have so this is a winning condition, sorry, going horizontally, this is a winning condition like this. Let me just quickly do it here. I'll just do it clear like this. So going all the way, the green side will be 1 2 and then 3. We have 4 5 6 7 8 and 9, right? Well, you know what, let's not count from 1. We'll just start counting from 0, because we need these values here. So it'll be 0 1 2 3 4 5 6 7 and 8. Okay, now this is clear. So now for us to win, we know we'll have to access the items. So horizontally, for example, horizontally we'll have 0, 1, 2, 3, 4, 5. Those are like winning case horizontally, right? And then we can have 6, 7, 8. Also, if you want to win vertically, you can go 0, 3, 6, or 1, 4, 7, or 2, 5, 8. Or diagonally, it will be 0, 4, 8, or 2, 5, 6, right? So again, this is quite so what we'll do instead is we'll create like a winning an array of winning conditions, right, or winning combinations, because I mean, to win you need more than one cell. So in total 3 cells to win the game. So you have to have your value in 3 places. Let me close this quickly. All right, so that's what we are going to do, and then we will begin to iterate through the game to see when somebody has won the game or not. Again, we're using this, I just wrote this here to know where to plot these values, right? The values in green actually represent the winning condition for us, right? So if we have a value, let's say x at index 0, 1, and 2, right? This means the x player has won, right? So, or if we have it at 2, 5, 8, it means the player x has won, or whoever has their value in those position has won. But for us to actually plot this on a 2 by 2, I mean 3 by 3 array, we actually need the index of each cell, right? We need to know where exactly each cell is so that we can change the value at that position. And instead of having an empty string like this, or an empty char, if you will, data type value here, we'll put in the actual character inside of that board. All right, so let's go ahead and do this. I will close this quickly and we'll get coding. So I actually wrote down the winning combo. So again, we'll create an int variable, so meaning the values inside of the array. Again, this will be a 3 by 3 array, so let's go in here. Oh, let's move up a bit, and then here is our winning combination. I'll just go back again, so let's go. Okay, so we do undo this and then go to the side. Okay, so we have an empty 2, 4, 2, 4, 6. Why is it like this? So we need 2, 4, 6 here. Back up again to the side. Yeah. All right, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 3, 6, and so on. So these are the conditions for us to determine if a user has won or not. Now, this means the values at these indexes, right, has to be the same. So we have to have x at index 0, 1, and 2 of our board here, right? Now, another interesting thing to note is that this board is a 2 by 2, a 3 by 3 board. So meaning we don't have index 8, index 7, or 6. We can only have 3 at the higher level, which is the parent level, 3 items, and then 3 items at the children level, right? The inner array. So what we'll need to do is to flatten this board to have 9 items in a single array. That way we can plot in the values at each point. So here's what I'm going to do. I'll first of all so I'll change this function here, right? I will move this out of the way because each time we are playing, we want to display the board, right? So we'll move this away so that we can, write the code for displaying the board each time. So let me do this. I'll do all right, so we are here. Let's come down to this place. Okay, go back up, down a bit. I don't know, say back here. I want to start copying the lines. Sorry, I'm still bad at this. So I'll go down like this and move to the left a little bit more here, and then copy that. Okay, so let's go back out and then undo that. I'll go back again. Just go down a little bit and just remove that. Okay, so what we'll need to do now is to, again, let's exit here. We'll create a function at the top here, right? Let's move on a little bit here. So we'll create a function here. I'll call this function display board. This function will just be responsible for showing the board each time we're playing the game, right? So I'll say this will be display board like this, right? Okay, I'm not going to say int. Come on, I shouldn't have done that. I just deleted the line. Anyways, I'll just say this function will return void. It doesn't return anything, so display board like this. And then what I'll do here is we'll actually need to pass this function a board to display, right? So the data type of this will be a 3x3. So I'll say char board. So I'm not sure if this is the right way to do it, but again, we want to pass in a 3x3 board to this function to display our board for us each time we are playing the game, or each time a user takes a turn. So, and then here, what I would do is I'll just put in the values I copied. Actually, let's undo that. Let's go back to a properly indented position. Okay, this is not bad. I think if we did this like this, I think it's okay. It's quite okay. So let's come back here and move to this side. We can close this now. Okay, let's move back up here and then set this. Okay, we have closed that. But yeah, I think so. What this function will do is we'll pass it this board array here, and then to display the values for to print out the board and then display the characters in each cell for us, because we'll be modifying this board as we play the game. We'll be plotting in the values at each point here. So let's go back down. Okay, so come here, insert, and then let's just try out the function and see how it works. So we'll say display board. Okay, this is what we want, and we want to pass it the board variable here, the board array, sorry. And this is much cleaner than leaving it here, because I mean we want to reuse this function a couple of times. So let's exit and write this here, and then we'll just open our terminal. I think if you do terminal, will this open the terminal? Yeah, but it's open it on top, which is not what I want. But anyways, let's just compile this cc and let's say app.c. Okay, so there's an error here. Oh, I didn't put in the actual value, so let's go back down and correct this. Okay, make the mistake. So wow, this is duplicate. What have I done? Okay, I'll just do this. Control back, control N. Let me just quit all of this. I need to like learn how to do this thing properly. Maybe I've forgotten how to really represent the board. Well, okay, so we'll come back here. Control. Oh, okay. We can do this. I think I can quit this. Alright. Oh no no no! I'm not quitting. Let's see. I'm still here, right? Okay. I mean, quit this. That's not the right way to do it, but I think I really forgot how to do it. So let's add the actual value here. Okay, so we'll go back a little bit. Yep. Close this. Right. I just say vertical term for terminal. Oh, I made it. This terminal does not move. Okay, it does actually. All right, so let's clear this. All right, okay, that's fine. And we can now compile this to see app.c. Compilation was successful. So now we can print out the board a.out like this. All right, so it is working. You can see our board is now printed, and we can reuse this function anytime we want to. Right, so let's close this again. Is it control? Okay, I'm not sure. When I like escape, doesn't do that, which is not good. So I'm not sure what I'm doing wrong, but I can't remember the command for closing this. It's like it's a window that has been opened, right? But the values are the window is still like not really following the Vim commands. So what I would do now is to just let me search how to do this. So I'll say here Vim how to close. I'm trying to look for how to do this. This creates a new window. Okay, so let's see. I'm trying to read this thing. I mean, this is just a minor thing, but since we are learning Vim and C, I think it's better to do this. Okay. I mean, I'm using the control// and control N, which is Well, I don't know. This puts you in normal mode. Control W, switch window. I mean, if I do this, Control W, it comes to this side. Control here. I mean, Control W, H will go to this side, but I can't get into the command mode now. Anyways, that's not a big deal. So we'll just leave it like that and continue with the rest of our game. So Control, I'll just do Control/Control N. It will now put me in normal mode, which I'll just come here and quit like this. All right. Okay, so we've defined our winning combos, right? Now, what we need is to find a way to ask the players to play, right? So we need to like create like a loop that will let each player take their turns. But before we do that, actually let's actually do that. So we'll say, how do we make each player take their turn? Well, we need a loop, obviously. We need that loop to run as long as the game is going on. So until we found a winner or the game is over, this loop will keep running. So I'll create a while loop and just put while one here. This is because I can't do while true without actually importing a boolean header, which I don't really remember what the header it's called. So I'll just do while one is truthy, a truthy value in C, so we'll just leave it like that and then do it this way. So we'll say while one printf, right, player, okay, so we'll need to define a variable for the player. This is also going to be the same data type as this, because this is what we'll be passing in the values of those players. So let's just escape quickly. Okay, let's just do this, and let's move upwards, I think here. All right, so okay, let's come here. Okay, let's move here a little bit. All right, so we'll say char here x. Okay, let's call this player. Player will be, what will we call this player? It will be x and o, but I want to make sure that we have a value to begin with. So I'll just say this will be player x, right? Again, it has to be single quotes because we are passing in these values into the char array here. Okay, so we need the player. So say printf player x. So let's just go back here and then insert. So we'll say player. So for the format specifier for char is C, so we'll just put C there. So say what player C is playing, right? So we'll leave this here like this and we'll pass it the value of player like this, right? Okay, now since we have this, how do we switch the players? How do we know, okay, player X has played, player Y needs to play now? Well, again, to do that is quite simple. Once the loop runs, once this player provides a value, right, we can determine, okay, all right, there's a value already here, maybe X is already X here. We'll just assign a new value to this player here and then change it to O, right? So again, we'll say here, let's go back here. Okay, go back up, escape, go up here again. Actually, let's move to this side here. I'll go to here and then put it here. Okay, so now what we'll do is sorry. Okay, so what we'll do now is to switch the players, right? So say player, so we'll use like a conditional statement here. Player, and they'll say if player is equal to, sorry, if player is equal to X, right? Let's do it like this, the actual X. Then let's change it to an O, right? So let's put O here, else we'll keep it back to X. Now this loop is going to act funny, but we'll see what's going to happen. So here we'll say player S is playing, right? This will start at first, and then this line here will run, and it will change it to player O, and then you see it printing on the screen till I don't know. Okay, but you know what? Let's say, let me just add a simple condition here to stop the loop from running, right? So I'll do this. I'll say here, I'll put O. I'll say int count is equal to 0, right? Is equal to 0. And then let's escape, move down. Come here, we'll say if, so we'll increment the count by 1, right? Is the count here? Count plus equal 1, right? And then what we'll do here is that let's escape this. We'll say if count is equal to 8, right? If count is equal to 8, meaning we'll see the player switch automatically. Then let's stop this too. So we'll say here break, right? We'll just break this loop here and then come back here. So we need to close our while loop properly. All right, so that is done. Everything is looking good. So we can come back here and write this file. So let's escape, write this file here. Let's do vertical terminal, vertical term, like this. I'll just keep the terminal there so I don't have to open it every time. So what we'll do is cc app.c. We don't have any errors, so let's clear this, and then let's run the code you know what, let me delete the init should be gone. So if I did here, a.out will be printed. Now you can see player X is playing, and then okay, let's add some line breaks here so that it looks good. Let's come back here. Let's move up to this line. Where is this? Okay, let's go back here. You know what? I should just be pressing E. I think it goes to the end of the line. So let's append here /n like this. Escape, right. Okay, clear this. Let's compile this code again. cc. I'll just make this mistake. cc app.c, and then we'll come back here and say a.out. Now you can see it's printed nicely. So we have player X is playing, then the second player will take its turn, right? And the reason why I put this count here, I mean, this is not part of the game, but it's just for like knowing when to stop the loop. Otherwise this loop will keep running forever. So again, player X is playing, player O takes his turn, and then player X will play again, player O, and so on. So they'll keep switching between each other. All right, so now what we can do next, let me refresh this window. I don't have any 1, 2, All right, this is good. So what we can do next is to actually write the logic for the game. Let me see, how can I reduce the window, the terminal window? Let me Google that quickly. Okay. So Control W will decrease the width of the window. Okay, so Control W like this. Oh, come on. Control capital W. Okay, Control capital W. Come on. Does that? Control reduce width. The windows to 89 height. I don't know. Is this like something you press and then you just do it later on? Control L, Control H here, Control W. Oh, I see. Control W, Control W, Control W. Okay. I see. All right, this is working. Okay, this is fine. I mean, this window here is bigger than this one, which is cool. I'll need to move my head away from here so that we see everything that we are doing. All right, so I'm back up here. I'll leave. I'm not sure where I should put my face. I'm not sure where I should put my face. Maybe I should keep it here at the top here like this. No, but that will close the stuff that I'm showing on the screen. Anyways, when we get to this point, I'll just move my face away from there. All right, so let's clear this. I don't know, I just like typing the clear command instead of just clearing it. I still feel this is too big, so let's go back again and reduce this window. So I'll do Control. Okay, this is fine. This is okay. I'll just keep it like this. So let's go back here. And we have, okay, so all right, cool. So what we'll need to do now is to write the logic for the players to plot their values in this board. So again, to plot the values in the board, we will need to get the points at which we want to plot the values, right? So again, we will first of all need to know, we'll define a variable for the rows and columns, right? So this will represent the cell. The cell has a coordinate for vertical and horizontal positions. So again, let's move back up here and let's come back here. Oh, I see. Undo this. Okay, come back here. So while we are still outside of this, so let's just define it here. I'll say int row. Again, this will just represent the row and columns. So row column like this, and then I will what else do we need? We'll need to find the length of our combinations. So winning combo length. So I'll just call this this will be like an int. So combo length like this will be equal to how do we find the size of an array? So we'll do size of the first element. So this winning combo, right? Complete this winning combo winning combo here like this, the actual array divided by size of the first element. Size of this will be 8 though, so we don't really need to do this. Actually, we don't need to, but I'll just put it here. Combo 0 like this, and then close it. Need the semicolon to terminate the program at that point. So what we will do now is to iterate through this, right, and plot the values. But we can't iterate through it the way we did here. I mean, this is just like looking at displaying the board. We need to iterate through it one time. You get me? Like, we have to do it one single time. In fact, we don't even need to do that. We need to iterate through the winning combo, right, to know where to put the values. I mean, to compare the current values in the cells of the board to see if the user has already won, right? Okay, so here's what we're going to do. We'll take this. Let me just put on. Okay, undo that. Take the O here. Think. Well, we have our winning combo length here. We have the row and column. We have this here, which is X, to determine the player who is starting. I mean, we could tell, we could set the starting player, but I mean, users can put any other values. So let's just restrict them to using X and O. Okay. So how do we need to first of all find a way to plot in the values, right? And to plot in the values, we need to hold on. Okay, so let's clear this. Well, I mean, we define the row and column values here. So meaning we can ask the users to put in these values here, right? So we just use scanf to get the values from the user. So we'll prompt the user twice to impute the column and row values for us, and then we'll now use that to like plot the value inside the board. So I mean, we don't even need another loop to iterate through this. We can still use the board like this, right? So let's do it this way. Oh, come on. So escape, go into normal mode here, and here's what we are going to do. We can say okay, prayer, let's leave this here. Undo, come down. I think here is better. All right, so you can say printf like this, and say we'll we'll ask the user to select a row between 1 and 3. I mean, we'll do the calculations ourselves because we don't want to say select a row between 0 and 2, right? So we'll just do the minus by ourselves later on. So we can see select, let's put select here. Oh, come on, select a row, a number, sorry, a number. I just put num here between, let's just put it like this, between 1 and 3, like this. Okay, between 1 and 3. Let's just put this here so that it looks more modern, and we'll put this here like this. So this is just a question we're asking them to answer, and then we'll use scanf, right? We use scanf here to actually assign the value they input in the terminal to a particular okay, let's change this to, come back up here, let's make this small. So we'll say I'll put here like this a bracket and call this column, right? Column selection. So this means we are selecting a column, right? So I'm saying select a number between this and that. So I'll just go here and okay, so here I'll say CC. I'll come out here, I'll just escape this. Okay, I'll just put this value here. Let's delete this line, delete that line there. So we say select a column, column selection, right, between 1 and 3. The reason why I copied this is because I don't want to type it again. So we'll use scanf here, scanf to the end of this, scanf, and then append to this. We'll say the value the user passes to this place will be an integer. So to get an integer value, we have to make it a D. So we'll say the format specifier for integer is D, and then pass it here like this. So we'll say this is going to be the value of the column. So just a column like this, right? Or should we do row? It doesn't matter, row and column. So we'll do column. So here, the reason why we are using this ampersand and column is because we are actually, as we are pointing to this, the location of this value, right? So we are telling scanf to assign the value that the user passes to in the terminal to column, which is at this position here, the location or the address of column. So this is a pointer assignment. So again, let's come back here. I will just do this scanf and then just put the new value here. Oh, okay, I did not get that. Okay, that was quite wrong. So dd, okay, we escape. Okay, dd, this is not working. So all right, that did not work the way I thought it would. So let's just go back here. So this is why. Undo this, undo that, undo, no, redo, Control R, redo that. Come down here, go back up, insert this, come here, escape, and then P. It did not work. So let's just go back again and do that, and then here let's just print F. We will just put in the new value here. I'll say this will be a row. This row selection. I'll say select a num between 1 and 3. Okay, so now here we'll just come here. All right, so we have this here. So we need the scanf for this as well. So scanf, so scanf, and then we'll say scanf of this value format specifier, because we'll put in an integer, and then we'll assign this to a row. So this will be a row, and then close this. Okay, yeah, like this. So scanf the and row. So now we have these values here, right? We have this one and we have this one each time. Okay, so what we'll do now is to come here and press on O to enter the new value. So we'll now get these values onto the board, right? So what we'll do here, we'll say board. Okay, board. Come on, I always forget to do that. Board at index. So we'll do row before column, right? Yeah, so we can do row minus, because the board here, right? The first items here are the rows, and the second item inside the first item of the parent one is the column. So just do row minus 1. We are doing minus 1 because we are asking the users to input 1 or 3, and we want to access the first row here. To access the first row, we have to get the value between 0 and 2. So we do minus 1 since the user has already typed 1. This will give us 0, and if they typed 2, if we do minus 1, it will give us 1, which will be the second value in the array. Okay, so this will be here, and then we'll do the same thing for the column. I think for the column will be minus 1, right? That will do quite nicely. Minus 1, and then we'll assign the player's value to it. So player like this. Yeah, so we only need to pass in the player like that. So again, we have this here. Now let's print the board again each time after the players are done playing, right? So we'll do board display board, I think display board here, and then we'll pass in the board, this board like this, and close it. So let's come out here, control here, write this code. Okay, so now we'll have cc app.c. Okay, there are some mistakes. Okay, there's a typo here, and implicit declaration function. Yes, size of is not a function. Sorry, that was my mistake. So let's go back up to find out where that is. I think it should be somewhere here. Yeah, where I defined the how did I miss that? I didn't see it actually. So let's go to the end, next word, and I will set here size of. Okay, so that's better. So now we'll come back here, write this, go back here, clear this out. Let's see after C come. This was done good. So now let's say app.c a.out. Let's run this, and you can see we are being prompted to choose a column between 1 and 3. So I'll put 3, and then to ask you again, select a column with a row between 1 and 3. Now here is a number between 1 and 3 for the rows. So if I chose 3 again, what will happen is I'll be selecting the third column and the third row. So X will be put into this cell here. So this is where S will appear. So let's run this. I'll come back here and press enter. As you can see, we've inserted X into this cell here. So player O is now playing, right? This is player O's turn. So we'll say 1 and 1, and you can see player O's value is inserted into this cell here, and then I'll do 2 and then 3 again, 2 and 3, you can see it here. Then the other person will do 2 and 1, 2 and 1, like this. You can see this is their own. 2 means, so since we are doing column first, right, we are selecting the second column, and 1 is the first row. Again, you can see the first row here. All right, so let's do this, the last one. I mean, the game will continue to the point where, okay, I don't like this. I'll just quit this. I'll quit this. So this will keep happening because, I mean, we are not asking the game to end. So this will continue upwards, at least in this case, until count is equal to 8, right? But we don't want that. Also, we also need a condition where if the value, I mean, let's just leave it like this for now and go back to, let's quit this. I'll clear this. Okay, it's gone now. So let's come back here. All right, so we have if counts here. This condition here is not really helping. I just left this here because we needed to test out how the board is displayed each time. But again, we still haven't, you know, achieved the actual logic of our game, but we already displayed the board, which is step 1. Step 2 is to plot in the values in the board. Step 3 is to now determine the winning conditions. Now we have something here already called the winning combo, right? This is winning combo here. So winning combo will determine when, I mean, the conditions for winning the game. But to actually show that the user has won the game, we need to iterate through the winning combo, right? We need to iterate through the winning combo and actually get the value at each position. They will now check if those values are equal, right? So again, to do this, we first need to get the winning combo. So we iterate through the winning combo and get the first one like this. Let's say we get the first one here, right? And we check, is the value at index 0 equal to the value at index 1, and is that value also equal to the value at index 2? If that's the case, then this means the user who is currently playing has won the game, and then we can terminate the game right there and there. Well, to even terminate the game, we also need another variable to track when the game is still going on. But for now, let's first of all do that. Okay, so we'll write a loop here. So I'll say for, let's call this J, right? For J is it okay, so we need the data type int J is equal to 0, right? J is less than the winning combo length. Sorry, winning combo. Okay, what did I call it? Combo length. Okay, combo length. Yep. All right, combo length, and then we'll do J plus plus. So we increase it each time. So again, we first need to get the first array, right? So we need to get the first array in the winning combination, and to do that, we have to assign that value to also okay, we have to assign that value, the value here, this here, to another variable, so that we can check if the values at each point here are equal. Again, I'm scrolling on my mouse, which is a bad thing to do in Vim. So I don't know, it just happens. You just default to that sometimes. It takes time to get used to Vim commands. As long as you have your mouse close to you, you use it. So we need to assign the array at each point in the combination, right, in our winning combo to a new variable. So we'll call this will be int. Since our winning combo, right, let's just come back here. Since our winning combo here is an array of integers, right, meaning each value here, each value at this point will be an array of integer. So to assign an array to a new variable in C, how do we do that? Well, it is quite simple, but it's not what you think, right? But let's just try the conventional way. So something we normally do in other languages is that we would do something like this. So we'll call this win, right? Let's just call it a win, and then we'll say winning combo, right? Winning combo here at J will be equal to this value. Well, let's see what happens when we do this. So again, we are trying to assign this value here, right, to win, which is our new integer type. Okay, so again, mind you, this here it is an array, right? So we are trying to assign an array to another integer, and you can see how it is defined. This is not going to work, but we should just try it and see for the sake of learning new things. Yeah, I actually did this and I realized why it didn't work, which I will explain in a bit. So let's come back here and write this Ctrl J H. All right, so when we try to compile this code, you can see there is a mistake. So it says initialize this is not printed as correct, but it's actually telling us what to do, right? This error message is actually brilliant. So it's telling us, okay, so we actually defined win as int, but we are assigning an array to it, right, which is an array of integers as well. But again, to actually do this properly, we need to assign the location, right, or the pointer value of this. We need to assign this here, right, which is the winning combo at J, at index J, to a pointer, right? So that win will point to the location where this winning combo is, right? That way we can access the value. Otherwise, we can't assign an array directly to an integer. This is not possible. So in C, for us to do that, we have to do it through the pointer value. Again, let's come down here. We saw the error message now, so let's go back up here. So to do this, we first need to I must always default into doing that. Well, anyways, insert mode, and all we need is this. So this is a pointer definition. So this will point to the location in memory where winning combo at index J is, right? So again, we'll exit and then we'll write this, and when we try to print this now, there will not be any errors. So I mean, when we try to compile, so again, clear this. I don't know why I keep typing clear. It's just a bad habit I have. All right, so our code worked just fine. Okay, so now we have win at this point. So what we need to do now is to compare the values at this position. So the value at this position here. But for us to do that even, we need okay, for us to do that, we need to get the value of the cells in the board, right? Because that's where we're actually checking for those values. We are not checking inside the winning combination. We're actually checking inside of the board, right, we're just using the winning combination to set as a highlight or a direction for where the values will be. Now when you look at our board here, our board is a 3x3 board. We don't have values at index 8 or 4, right? Our board will always go from 0 to 3, and then inside of each one of them from 0 to 3 as well. So what we need to do is to flatten this board so that we can have values from 0 all the way to 8, right, which is this winning combos length actually. So there is a simple way for us to do that. Actually, what happens is that in memory we don't have the board, we don't have a 3x3 representation of the board. What we actually get is an array of all the values packed together, right, or spread into a single array. So what that means is, if we point to the location where this board is, right, we'll see that we have an array of 8 elements, right, 8 elements. So again, let's do this. I'll go back up here, so increase O, and then we'll do this. We'll define a flat board which will point to the location in memory of this this board here. So int, oh, it's not going to be int, this is going to be char flat board, right? Let's call it flat board and set it to be equal to the location in memory of our board array here. So we'll say here this is going to be like this, and then we'll set this, we'll put it like this. Okay, I made a mistake here. So this will be like this, flat board, right? Flat board, because we're assigning the location, the pointer value of this here. So we'll say char like this, and then we'll put it as board. Okay, so this is all we need. Now we can move on to the next part. So we can come back here, and so we have our winning combo. So the win combo for the first iteration could be 0, 1, and 2, right? 0, 1, 2, and then this will run for all of them. So when we get to this point, like somewhere like 3, 4, 5, right? 3, 4, 5, we don't have 3, 4, 5 in board. We can't directly get 3, 4, 5 in board like this. But if we point to the location where board is stored, we'll be able to access those values at those specific indexes. So again, we'll do it here like this. So we'll say, again, let's come back here. I will go down a bit and say, oh, here we say we'll say this will be okay, so we'll say let's call this, is this going to be, so this will be char, right? This will be char, and we'll say A, we'll call them A, B, C, right? These are the values at the winning combos index inside of our board, if that's not too confusing. So again, we'll say flat board, let's come here, flat board, Control N, and then we'll set it to be win at index O, right? So we'll get the value at index O, and let's put it here and say char here B. We always need 3 values, right? So flat board, flat, oh, is this how I wrote flat board? Oh, somebody pointed it out. You missed A in flat board. Thank you, Christ. All right, so let's come back here. I will go back up. Okay, let's move back. All right, so I'll move here. I think board, append here. Okay, it's just putting in. I should have done insert instead of append. So board, yeah, board is there. Okay, so now we can move back down here. Oh my god, Just remove this. Okay, so let's escape. Down, 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 down. Up, 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 up. So go to here. Let's come here. Insert a, okay, now we have board correctly written. So let's come back here. Control, escape down. Sorry, I'm very slow with Vim because I'm still learning it. I'm nowhere close to understanding how Vim works, but again, I'm just up for the challenge and learning it as time goes. So we'll do it like this. So we'll say win at index 1 here should be like this, and then char, let's call this C, is equal to flat board, come on, okay, this is my fault, flat board here like this at win index 2. Okay, so this would be like this. Oh, nice. Say it started with new Vim. That's cool. Yeah. All right, so here's what we need to do. We'll first compare the values, right? So we already, at this point, we have some values here that we can now compare. Because again, the iteration, this here selects, this here is an array. Winning combo at J, or win here is an array. And this array has 3 elements. It's an array of 3 elements. So, which is why we're able to do 0, 1, 2, right? So again, we've gotten these values here. So we can now compare them and see if they are equal. Okay, so let's come back. Okay, let's go exit, come down here, and then do this. So it will say, first of all, if the value at A, okay, let's move that a bit so that it looks more nice. If the value, okay, I'll scroll back up so this is in correct view. So if the value at A here, first of all, we need to make sure that the value is not empty. So if the value at A is not empty, okay, there's a space inside. There has to be a space because that's how we defined the char variable. So if this value is not empty, right, and the value at A, come on, the value at A is equal to the value at B, and the value at B is equal to the value at C, B is equal to C, then it means the user has won the game, right? Simple. Okay, let's just move back up here. Come on. Oh, I keep making this mistake. Anyways, so if that's the case, we'll display the board. Display board again. Really? What was I writing? Display board. Oh, come on. You should have done that for me. Display board. We'll pass in the board again. Here. Okay. And we'll print a message here. So printf player. Okay, let's just say printf. We'll just print on a new line. So say player. What's that player again? C, right? Has won. And we'll just close this and pass in the player variable here. Close this like this, and we will break this loop. Break. Now this will only break the for loop here, right? But let's try and see how we can end the entire game altogether. So we have this count here, right? We have this count here that keeps increasing, and this count breaks the game for us when it reaches 8 iteration. So instead of using this count, I will just go back up here let's define another variable, right? Let's define another variable here called game over. So I'll go back up here and say int game over, like this, right? Int game over, and we'll set this to be equal to 0 at first, right? 0 is false. 0 is a false value. So as long as game over is not equal to 1, the game will still go on, right? The game will continue. I mean, even in the while loop here, instead of passing 1, we can't pass game over. We cannot do that. We cannot. It won't work. So we need to leave it at 1. So let's go back here and let's, oh, what's happening? I made a mistake. Did I? No, I didn't. So let's come here. I'll move up a little. Okay. Okay. We won't break here. Before we break, we'll first assign a value to game over. So say game over should be control. Complete that for me. Game over should be equal to 1, right? And then we'll come back down here. Let's exit. Okay. Player. Up. All right, so we'll just go to visual mode and delete this line. Yeah, we'll delete that. We'll even delete this. Let's move up a bit and then come here. I think we are still in the, so this will break the for loop. We'll quickly exit from it, and then we need another condition to break the while loop. So again, it'll say game over if, okay, the condition was such that if game over, right, is equal to, if the game over is equal to 1, right? We don't even need this. We can just say if game over 1 is already truthy, right? If game over, then break like this, and then we'll, oh, okay, sorry, we'll close that. All right, so I think our game is pretty much done, right? So we can then go ahead and try this out. Hope, oh, okay. I mean, if there are any errors, we'll solve them one after the other. Otherwise, I think this is pretty much done. So here's what we need to do. We'll just move to this terminal here. Again, clear this. I'll do Control L now. Oh, see, I typed it again. I don't know why I do that. Okay, there are some errors. Okay, so something happened that we, okay, so first of all, player was defined. I mean, I passed in the wrong value, and there is another error here. So this error says what, expected expression before char, board char here. Oh, okay, so undeclared. Oh, okay, I need to find out why this is happening, so I can explain this better. Okay, so again, we said a function main, in function main, unexpected expression char, unexpected expression before char. So what does this mean? I mean, the second error I know, so let's quickly solve that one and get it out of the way. So here we just go word. So here we just replace this with p, a small letter p. Yeah. All right, so we're here. We can write this now, and our error should reduce. Let's see, and you can see we only have one error now. This is the only error we have right now. All right, so what's this error and how do we resolve it? How do we solve this error? I think it has to do with pointers and how we are referencing a value. But let me quickly find out why. The dun, 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 dun. Okay. All right. So I saw there's something called a C style cast syntax. To flatten an array, the cast operator converting to a pointer. Okay, so we are well. So there's this thing called a pointer cast in C. So here's an explanation for what's going on. I think we have so interpretation. Casting a pointer alters the compiler's view on the data at memory location. For instance, casting an int means differencing the child will read a single byte of child from that location. While differencing this is not what I mean. Yeah, so character pointers can be used to examine byte level representation. Okay, so let's check here. Something is wrong. Let's go main int here. I mean, this pointer differencing, so not really. Thinking about pointers, it helps to draw diagrams. A pointer is an arrow that points to a memory address. Okay, an address memory with a label indicating the type of value. The address indicates where to look, and the type indicates what to take. Casting the pointer changes the label on the arrow, but not where the arrow points. Okay, so we say in main pointer. I think type differencing is pointer casting. I'm not sure. That's like the solution. Yes, that's error. Okay, so there's I see. So first of all, we have this here. Oh my god, so we have this thing here called I'll just move up here. Okay, so here we will go da 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 da. So here we have this flat board. Da, da, da. Okay, so again we are changing the type of one. We're changing the type, right? Okay, I have somebody. So say I guess because both are treated as undeclared pointers, maybe declaring separately and then assigning will work. Yeah, I also read that because we defined this board here as an array of array, right? Which is an array of character. It's a 2x2 array, but we are trying to cast it into a different data type. Again, we are passing the memory in location of board to flat board, right? We are pointing to these flat boards. We are pointing to the flat boards pointer, right? So all we actually need to do is to cast this into the type of flat board. And to do that, we actually need to insert some parentheses around it. This is what we should do. So again, if we had int, an array of ints, and then we want to assign it to a single character int type of, a single int type of flat board, if this was an int, we needed to pass it to this guy here. Like this, I think this should solve the issue. So again, we'll go back down here, right? And come back here. Let's clear this again and then run it. Okay, the compilation was successful. Maybe declaring separately and then assigning. We want flatboard to be an array of a flat array, right? Meaning we don't want like extra values in it. So I'm not sure if that's going to work, but I'm not sure how to do that. So if you can type it in the comment section, that would be nice. Well, anyways, we're done with this. So now let's play the game. So we need to play the game now. So I'll come back here. I'll clear this place again and then do, okay. So we'll do a.out. So we say select a column. I'll select column 1, row 1. Now you can see X is here. So we'll set column 2, row 2. Okay, you can see there. I just want one user to win, so I can just like what's this again? I'm like scrolling on the mouse. Christ, this is annoying. So we'll put will this work? Column 1, row 2, column 1, row 2, like this. Okay, yeah, those values were nothing. So now you can see we have X here. I'll put for O, we'll just put column 3, row 3. Okay, I just want player X to win so we can see if the game will end or not. So let's go again. We'll put row column 1 still and row 3. And you can see player X has won and the game automatically ended, so we cannot continue with the game anymore. But this is strange. What's this? We have XSS. Are we still printing the board afterwards? Column 3 we have, the board is printed twice, which I'm not sure why. So let's go back here and see if something else is happening. Game over. I'm not sure what just happened, but okay, let's go back here. I think let's go back here and try to, I mean, my time is up. I'm supposed to do this for 1 hour, but I just want to finish this game so we can build something else later on. So let's clear this again. I'll just run this one more time. Let's try the diagonal win and see if this will work. So to win diagonally, the values have to be at 1, column 1, row 1, column 2, row 2, column 3, row 3, or any other diagonal value is fine. So let's go column 1, row 1. So this will be 2. I'll just put 1, column 1, yeah, row 2, just to create that value there. So let's go down. So this will be column 2, row 2, and then this will be 1, and then row 3. I'll just put column 3, right, row 3, and you can see the player has won and the game is over. I'm not sure why this is printing twice. What's going on? Player, board. There's another board being printed. Let's clear this. So go back here. Let's make sure that something else is not printing this board, or maybe the board is being called somewhere. Flat board. It's a function. Display board. Display board is called once, and then we ask the players when they want to play, right? I'm not sure why this is happening. Okay, I am not sure. Maybe, oh, I see. Maybe because we're not printing in a new line after we say the game is over, right? Maybe. Anyways, let's try and find out why that is happening. We end the game, right? And then game over. I mean, if this is game over, we break the loop. So this should not even come up to this point. Is there anywhere else where printing display board? Display board is here. It prints just once. And then we add the new line here. But this is printed twice. That is not nice. Well, anyways, we need to add more. Okay, so he said, then I was thinking about char board, and then finally flat board, and then board. Oh, okay. I mean, let's try that and see if it will work. I'll come back here. Just like insert. Let's comment this out. And then let's say here we want flat board, right? So it says what char flat board, and then char board, and then finally flat board equals to board. Is this possible? I mean, we can't do char board like this here without this parenthesis, because the board itself, right, if that's what you meant, then this will not work, because the board itself is it's a different data type. So we are casting it into a new data type, and we need to like put the parentheses around it. I'm not sure if I'm explaining it well, but basically what's happening is we said char. We're saying char is equal, I mean board is equal to char of 3x3 array, but then we want to access the value, or we want to point to char in memory, and we are saying point to char that is this, but char, I mean point to board that is char of this pointer here. Meanwhile, board was defined differently here, so this is not possible. right? This is not possible. We needed to put it in parentheses and tell it to change the type of it, which is why we are putting the parentheses around it. Yeah. All right, what I would do here is I'll just exit again and undo my comments. I'll post this to GitHub and leave the link in the description below. I think I'm done with this. I'm not done per se. There's still more edge cases, like when the player tries to assess a value. I mean, when the player tries to impute a value at a place where there is already a value. Because now, if we did that, you'll see the value would change. Let's quickly try that. Control W, yeah. All right, so clear this. I don't know why I keep typing clear. Okay, so we'll put 1 and 1. And let's say this player also chose 1 and 1. You can see the value here has changed, but we need to find a way to prevent that from happening and then enforce or force them to actually enter the value we want them to enter. So again, we'll do this later on. I think my time has gone. It's almost 2 hours since I started the stream. Okay, sorry about that. I hope you enjoyed this. And user, I don't know your name, but thanks for watching. Thanks for coming around and hanging out here. All right, guys, thank you for joining my stream today, and I'll see you